So, in Palmer, Oates and Portney's framework, they have drawn a simple diagram. In the x axis, they measured abatement level. And in the y axis, they have simply measured dollar or rupees or whatever. What is the advantage of measuring everything, putting dollar in the y axis? Because you can measure the cost of abatement, benefit of abatement, everything, because everything has to be measured in monetary units. That is why we are measuring only dollar in the y axis, or you can put rupees on the y axis. Let us say that the initial, this is called marginal abatement cost curve, marginal abatement cost. Okay. Now, why the marginal cost? Why? The question that I am asking, why is the MAC curve upward sloping? Can you think of why is this MAC curve upward sloping? So, that means for every additional unit of abatement, your marginal cost of abatement is actually going up and up. So, every additional unit of abatement becoming costlier than the previous unit. What is the logic? What is the logic? Can you think of why the MAC curve is upward sloping? Why every additional unit of abatement becomes more costlier than the previous one? Now, to answer this question, you can apply one simple logic, that when at the initial level, when abatement level is very low, that means there is too much of emission. When emission level is too much, then it is very easy to clear the emission. As you keep on abating, the pollution level or emission level will come down, and it would be very hard to clear the environment even further when it is already cleaned. Suppose I am asking you to clean this room which is full of dirts. So, initially it would be very easy for you to clean a unit of dirt when it is already very dirty. But if you keep on cleaning this room, at one point of time, the room would be so cleaned that it would be very painful for you to clean that room even further. That means the simple technology cannot clean a room which is already cleaned. So, that means you cannot clean a room when it is already cleaned by simply the simple jharus. Probably you have to bring in the high power machine like Dyson and all, which is used, the vacuum cleaner which is used to clean our room. So, that means when emission level is very high, cost of cleaning is low. When emission level is very low, cost of cleaning would be very high. Based on that logic, we said that MAC curve is upward sloping. As you keep on abating, pollution will come down, and every additional unit of abatement becomes costlier. That is the reason the MAC is upward sloping. The answer is every additional unit of abatement becomes costlier than the previous unit. That is the logic. Okay. Now, suppose the effluent charge is P1. The policymaker set an effluent charge which is P1. Now, at this P1 emission charge, what should be the equilibrium level of abatement? Can you think of? This is the emission level, sorry, this is the emission charge, that means emission tax or effluent charge, whatever you may think of, that is P1. How the firm will decide how much to abate? Now, we have to keep one thing in mind. Once tax is imposed or any effluent charge is imposed, firm they have two options. Okay? What are those options? Option number 1, go for abatement if MAC marginal abatement cost is actually lower than the charge or tax, and secondly, go for paying tax if tax is lower than MAC. That is very simple. So, the firm can either pay the tax or go for abatement. What they will do? They will first see for 1 unit of abatement what is the cost and what is the tax rate. So, as long as the tax rate is higher than marginal abatement cost, obviously it is beneficial for the firm to go for abatement than paying the tax. Okay? So, that means optimality is achieved when this P is actually equals to the MAC. So, that gives optimum level of abatement. So, that means you have to simply equate this. Okay? Simply equate this, and your this is, let us say, X star is the optimum level of abatement by equating P equals to MC. Let us say that this is point number B. Okay? This is point number B. They have simply equated the tax with the marginal abatement cost and decided about optimum level of abatement. So, this is called optimum level of abatement. Now, suppose firm can invest more in this MAC technology, that means abatement technology, so that per unit cost of abatement goes down. So, that means if the firm invest in R&D to come up with better technologies, this MAC will shift from, let us say, MAC to MAC star. That is possible. Okay? So, shift from MAC to MAC star is possible by investing in abatement technology. Abatement technology. Now, whether the firm will invest in that technology or not, that depends on what is the benefit of that and what is the cost of that. Okay? Let us first give different name. So, let us say that this is this is C, let us say this is O, let us say this is F. Okay. So, let us now think about what is the benefit. What is the benefit? Benefit of investing my money into that R&D so that MSc shifts from MSc to MSc star. Now, when MSc shifts from MSc to MSc star, there are two benefits. Firstly, what will happen? The benefit number one, every unit of abatement becomes cheaper. Every unit of abatement becomes cheaper. See, earlier for this unit of abatement the cost was this much, but now this is be only this much. So, that means there is some kind of saving. So, for each and every unit, that means there is some kind of saving. Since abatement becomes cheaper, the firm can actually save some money for every additional unit of abatement. If you add all this benefit, then this OFB, this would equals to O, the triangle OFB. That is the first component of the benefit, which is generated because every additional unit of abatement, it becomes cheaper. Okay? And what is the second one? Second benefit is that for every, with the new MSc card, you can actually abate more amount of pollution. Okay? If the pollution charge is fixed at P1 instead of B, now you can go up to C. So, that means you can go from X star to X1 star, and that will give you another benefit. Okay? So, that means this is actually the triangle BFC, right. So, this plus this, if you add, then that is actually equals to OBCF. OBCF is actually total benefit of the investment. So, if the firm invests money in R&D to come up with better technology so that MSc shifts from MSc to MSc star, there are two types of benefits the firm will enjoy. Firstly, OBF, the triangle. Why it is generated? Because every additional unit of abatement becomes cheaper. Secondly, when it is cheaper, given the tax rate P1, firm can actually go for higher level of pollution abatement. Initially, they were abating up to X star, now they will go from X star to X1 star, because tax is equals to MSc happening, this condition P equals to MSc is happening only at point C. So, this is the total benefit. Now, if the firm is operating at point B, that means what we can say, that cost of such investment, cost of innovation is actually higher than the benefit measured by this area OBCF. So, that means what we can say, that if cost of if the firm decides to operate at B, that means the benefit measured by OBCF is actually less than cost of R&D, cost of R&D. That is what we can say. Okay. So, this is the pre-regulation scenario. There was no regulation. Okay. That means regulation was there. I mean, regulation was a modest amount. It was not so stringent. Only P1 amount of tax is imposed. Now, according to Porter, we need to analyze if the tax rate increases from P1 to P2. Let us say this is P2. What will happen? Whether the increase in tax rate from P1 to P2 can motivate the firm to go for innovation. At P1 level, we have just established that the firm decides to operate at B because the benefit amount is lower than the cost of R&D. So, at P2, firm has actually two options: either to stick to the old technology and operate at H, or to go for innovation and operate at D. Now, what we have to show that neither H nor D is actually better than B. How to show that? Please try to understand. I will repeat once again what I am saying. Previously, when the tax rate was P1 set at a very moderate level, that was not enough to motivate the firm to go for R&D, that means the technological innovation which could possibly shift the MSc from MSc to MSc star, because the benefit amount measured by OBCF is less than the cost of such R&D. Now, according to Michael Porter, stringent regulation may induce the firms to go for innovation, and that is what we are doing. We are increasing the tax rate or effluent charge from P1 to P2, and we will examine whether at P2 level of emission tax or effluent charge the firm can actually go for the innovation or not. So, what is happening at P2? At P2, firm can actually operate at H with old MSc or at D with new MSc, which is MSc star by technological innovation. Okay. We have to show that neither H nor D is actually better than B. How will you show that? Let us first think about the old MSc. Now, along the old MSc, it is very straightforward to show that B is actually profit at B is greater than profit at H, because the firm is facing the old MSc curve, effluent charge has increased. So, the firm is actually abating more with the old technology. So, what will happen? Obviously, profit at H would be lower than B. So, that means what we can say, along MAC we can show that B is actually greater than H. B is greater, very straightforward. My technology is old and the new effluent charge is asking me to abate more. So, obviously, profit will go down. So, B is greater than H. But H and D is not directly comparable. H and D is actually not directly comparable, because at H you are facing the old technology and new tax rate. At D you are facing actually the new technology with the new tax rate. So, since H and D are not directly comparable, what we will do? We will think about along MAC star what is happening. Along MAC star, if we compare C and D, then again it is very straightforward to see that profit at C is actually greater than D, because following the same logic, at D the firm is actually going for higher abatement and tax rate is higher. Okay. So, C is greater than D. C is greater than D, very straightforward, and we have already established that B is greater than C. So, from this when the firm decided earlier to operate at B, that means B is greater than C, that we have already established. Firm was not interested earlier to go for innovation because B is greater than C. So, that means earlier we established B is greater than C. Now, if you apply by law of transitivity, we can show that B is actually greater than D. B is greater than C, C is again greater than D. So, what I can say that B is actually greater than D. Now, even though the framework is very simple, it is highly powerful. Why this is powerful? Because with this simple model, Palmer, Rhodes and Portney, they could actually establish that if innovation was not profitable with the modest amount of regulation, it is still not profitable even after making the regulation so stringent. What Michael Porter said, that if you make the regulation more stringent, then that will lead to more innovation. That is actually not true. That is actually not true. It is a simple diagram they have nicely explained. Okay? This is the framework. So, that means the cost component, what was completely missing in Porter's argument while judging, evaluating regulation, they have introduced. Okay? If you impose regulation, more regulation from P1 to P2, what is the cost of it and what is the benefit of it? So, benefit is basically when the MAC shifts from MAC to MAC star, this is the benefit OBCF. And what is the cost? Cost they have also analyzed. So, when you introduce cost and analyze the situation in a benefit cost framework, then you can actually show B is greater than D. So, that means if innovation was not profitable with a modest amount of effluent or emission tax P1, it is still not profitable even when with a increased effluent tax P2. That is what they said. Of course, there are certain limitations in Palmer, Rhodes, Portney's framework also. What are the limitations? The limitations of this framework, the limitation of Palmer, Oates and Portney's framework. Firstly, their model is also a static one. Their model is also a static one. Okay. Why this is a static one? Because they have not analyzed, they have not analyzed the strategic interaction between the polluter, and here it is the firm, and the regulator. Okay. So, over time there would be some kind of strategic interaction. The moment I impose tax, the firm will strategically behave, okay, strategically decide about their level of pollution. Then in next time the regulator will also decides about the level of emission tax. So, that means in a repeated time framework, that means in a game theoretic framework, multiple shot game, in a dynamic game actually, it is possible to analyze such kind of strategic interaction between the polluter and the regulator, and also strategic interaction between regulator of one country with the regulator of another country. Once the regulator impose regulation in India, how the regulators in China, Pakistan, US and other countries will behave. Also regulator of one country will also strategically interact with regulators of other countries. So, these are the main two limitations, but even if we make the system dynamic, the main proposition of this model, what they said, that if innovation was not profitable with the modest regulation, it is still not profitable with the stringent regulation, that still holds good. But the main proposition of the model still holds good, even if you make the system dynamic. So, that means what we have discussed so far. First we discussed about Porter's argument, then we discussed about Palmer, Oates and Portney's argument to challenge Porter's this thing. But interestingly, because of this huge importance of this Porter hypothesis on policy making, even today people are trying to, empirical researchers, they are trying to find out whether Porter's hypothesis is actually true or not using empirical data. And not only that, there are researchers, they are asking additional question. What Porter said, that regulation will create an win-win opportunity. But if we ask, does win-win opportunity always result in pollution abatement? That means, so far economists or empirical researchers, they are asking this question, whether Porter's hypothesis is true or not with empirical data. So, that means whether regulation is leading to higher level of output and lower pollution or not. But if we ask this question, even if such win-win opportunity exists, whether such opportunity will always result in pollution abatement or not. And I have one paper exactly on this title, where I actually examined this particular question, and I showed that even if there is win-win opportunity resulted from the regulation, there is no guarantee the firm will always go for pollution abatement. Rather, what the firm may try to do, they will try to bypass the regulation with some illegal negotiation with the pollution control authorities. Many times what we see, that these polluting firms and these regulating authorities, they have some illegal negotiation. Pollution control boards, they are sending some officers to examine whether the regulation is properly implemented. But what happens in reality, these polluting firms, they bribe these officers. That means there is a possibility of illegal negotiation, and that because of this illegal negotiation, even if such win-win opportunity exists, they may not result in pollution abatement. So, we have one paper, that paper we will discuss in a later context, wherein we will be discussing how to measure environmental efficiency of the firms. So, that means how to measure cost of abatement, cost of regulation. We have already told that in Porter's argument, the cost part was missing. Now, the framework what we have applied in our research, there is one clear advantage. It will help us understand what is the cost of complying with the regulation. So, we showed that if such cost of compliance is higher, then that may not always lead to pollution abatement. Rather, firm will always try to bypass the regulation and produce even more output. Of course, they will become efficient, but they will avoid the regulation. And how they will avoid? By this illegal negotiation, that means there is some kind of transaction cost, of course. So, if the transaction cost is lower than what the benefit they enjoy, firms will always try to bypass the regulation, and that we clearly demonstrated in our research. That we will be discussing in a later part. Thank you.